So we have already understood what happens to significant figures when we do addition, multiplication, subtraction, and division. Now, another common operation that we do is logarithm and anti-logarithm. So those are commonly used in engineering to do complex calculations, and thus we need to find out what happens to the significant figures when I'm doing log base 10 of a number. So here is a simple example. The first thing that we do in such cases is that we express the number in the scientific notation. So log base 10 of number expressed in scientific notation, this would have the same number of significant digits as my a. Okay, so this is an a, so I express the number in the scientific notation in the form of a into 10 raised to power b. So my final answer would have the same number of significant figures as my a in the scientific notation. So here my number has my a basically in the scientific notation. It has number of two significant figures. So my final answer would have two significant figures. You can look up the tables. This answer would come out to be minus 3.346, and then there will be some more numbers, but of course we are not really interested in those. And why is that? Because we only need to keep two significant figures, because here in the scientific notation the a had only two significant figures. So this is what happens when we do log. So my final answer would be 3.3. So this applies to log base 10, which is what we commonly use to do the complicated calculation. The same rule can be extended for other logarithms if you are so interested. Now what happens when we do anti-log? So if I want to do this, let's say I want to do an anti-log of 1.55, 5.15, then this essentially means, this operation actually means we are trying to find 10 raised to power 5.15. That is what this means. It's the inverse of the logarithm. So we'll do the 10 raised to power this number. And the idea is that again, when we go to the answer, although the answer might have many decimal digits, from these digits we choose only those many significant figures as were there in this power. So because this anti-log, the operand had three significant figures, from here we will only choose three significant figures, and my final answer would be, okay, so this is what my final answer would be. Okay, so I chose only three significant figures. So just write this here so that it's clear. So hopefully this makes sense. With this we complete the entire ambit of operations with respect to significant figures, what happens to each one of those. If you have questions, definitely put them in the comment section, and do practice as many numericals as you can, because ultimately that is what will build your expertise. Thank you.